Logical entailment for Herbrand logic is defined the same as for propositional logic. A set of premises logically entails a conclusion if and only if every truth assignment that satisfies the premises also satisfies the conclusion. In the case of propositional logic, we can check logical entailment by examining a truth table for the language. With finitely many proposition constants, the truth table can be large, but it's still finite. For Herbrand logic, things are not so easy. It's possible to have Herbrand bases of infinite size, for example, when the language contains function constants. In such cases, truth assignments are infinitely large, and there are infinitely many of them, making it impossible to check logical entailment using truth tables. Fortunately, all is not lost. As with propositional logic, we can define a proof system for Herbrand logic. And interestingly, it's possible to show that, with a few simple restrictions, a set of premises logically entails a conclusion if and only if there's a finite proof of the conclusion from the premises, even when the Herbrand base is infinite. Moreover, it's possible to find such proofs in finite time. Sadly, things are not quite perfect, though. If a set of sentences does not logically entail a conclusion, then the process of searching for a proof might go on forever. And moreover, if we remove the restrictions I mentioned earlier, we even lose the guarantee of finite proofs. Still, this relationship between logical entailment and finite provability, given those restrictions I mentioned, is a very powerful result and has enormous practical consequences. In this lesson, we start by defining a proof system for Herbrand logic based on Fitch. We then illustrate the system with a few examples. And finally, we talk about the soundness and completeness of the proof system given various restrictions.